Welcome, Matayam 2 students or grade 8 students. I'd like you to study this course on chapter 7, Earth. I'll be speaking so slowly so you can translate this one into Thai language and you will be ready for the midterm test. All right? So let's talk about the Earth. You can turn also your book to chapter 7 later on this topic about the Earth. So, topic 7.1, layers of the Earth. Okay, I want you to translate the whole chapter about this topic, and then I want you to answer all the questions. But before you answer all the questions, I want you to watch this video carefully so you will be able to study and learn more about it. All right. So here, how many layers are there in our Earth? Okay. What is your answer? Type your answer right there at the bottom in the comment section. As you see here are the layers of the Earth. We have this part in the drawing. You will see our Earth consists of 3 layers: the crust, the mantle, and a core. Okay, so the crust is made up of rocks and minerals. Much of the crust is covered by water, sand, soil, and ice. Below the loose layer of soil, sand, and crumbled rocks found on Earth is the bedrock here, which is a solid rock. Now, the crust makes up 1% of the Earth's mass. There are 8 elements that make up 99% of the Earth's crust. They are oxygen, magnesium, aluminum, silicon, calcium, sodium, potassium, and iron. The continents are about 35 kilometers thick, and the ocean floors are about 8 kilometers thick. The mantle is the layer below the crust. It is the solid casing of the Earth and is about 2,900 kilometers thick. It makes up about 70% of the Earth's mass. It is made of silicon, magnesium, oxygen, aluminum, and iron. Its temperature is between 500 degrees Celsius and 2000 degrees Celsius. That is very hot. The core is the center of the Earth. It makes up about 30% of the Earth's mass. The outer is mainly made of molten iron and nickel, and it is about 2,200 kilometers thick. Its temperature is between 4,000 degrees Celsius and 6,000 degrees Celsius. That is even a lot hotter. The inner core is 1,270 kilometers thick and is made of solid iron and nickel. This is mainly due to the extreme pressure. Its temperature can be as high as 7,000 degrees centigrade or Celsius. Really hot. Now we have some hot tips. How are the layers of the Earth similar to an egg? We have the crust is equal to the eggshell. The mantle is equal to the egg white. And the core is equal to the egg yolk. Aren't they similar? Now, we don't need to watch this video about the Earth's chemical composition, but if you want, we can watch.
Planet Earth. Have, Planet Earth. Have you ever wondered what it's made of? You're probably thinking the answer to this question is rocks, but what are Earth's rocks made of? In this video, we will find out which chemical elements make up our planet. We will also discuss how Earth's composition varies with depth. And finally, we will take a look at Earth's inner layers. You might be familiar with the periodic table of elements. It lists all of the known chemical elements by their chemical symbol. On Earth, there are 94 naturally occurring elements, but only a dozen of them are actually common. In fact, about 90% of the Earth is made of only 4 elements: iron, oxygen, silicon, and magnesium. These 4, plus nickel, sulfur, calcium, and aluminum, account for more than 99% of the mass of our planet. However, if you were to analyze a rock you found on the Earth's surface, it is quite likely that you would get a slightly different result. This is because chemical elements are not distributed evenly throughout the Earth. In fact, Earth is divided into 3 layers that have different compositions. In the uppermost layer, called the crust, the most common element is oxygen, followed by silicon. If you are surprised to discover that oxygen makes up most of the Earth's crust, it's because when you think of oxygen, you are probably thinking of molecular oxygen, or O2, which is a gas at surface conditions. Oxygen in the crust is not a gas because it binds together with other elements to form solid chemical compounds. So oxygen and silicon, together with 6 other elements, aluminium, iron, magnesium, calcium, potassium, and sodium, form the vast majority of the minerals that make up the rocks on the Earth's surface. If you compare the composition of the crust with the composition of the whole Earth, one of the things that immediately stands out is that the crust seems to have a lot less iron. This is because iron is a heavy element, so gravity has caused most of it to sink to the core. On the contrary, compared to the rest of the planet, the crust is enriched in lighter elements, such as aluminium, calcium, potassium, and sodium. Let's consider a cross-section through the Earth from the surface down to its center, nearly 6,400 kilometers below. At the Earth's center, we find the core. This iron-rich layer extends for roughly half of the planet's radius, and with a density in excess of 10 grams per cubic centimeter, or 10 times the density of water, it accounts for most of the Earth's mass. By contrast, the uppermost layer, the crust, which is very thin and extends on average for 30 kilometers below the surface, is made of much lighter rocks. Between the two, at depth between 30 and 3,000 kilometers, we find the Earth's mantle. Despite this differentiation into progressively denser layers, the composition of each layer is not determined by the relative weight of the chemical elements alone. In fact, as we have mentioned before, the elements bind together to form compounds, and it's ultimately the properties of the compounds, such as the compound density but also their melting point, that control the distribution of elements in the different layers, rather than the density of the elements themselves. For example, silicon and oxygen readily bond together to form a compound which can be represented with the chemical formula CO2. Geologists commonly refer to this CO2 compound as the mineral quartz. Silica and oxygen also like to form bonds with calcium, sodium, aluminum, and potassium. In this case, a group of minerals which goes by the name of feldspars is formed. Like quartz, feldspars have relatively low density and melt relatively easily. Geologists speculate that when the Earth was young and hotter than it is today, these compounds formed silica-rich melts, which rose to the Earth's interior due to their low density. As the melts reach the surface, they cool down to form the crust. This explains why quartz and feldspars are by far the most common minerals in the Earth's crust. Other common compounds of silicon and oxygen involve iron and magnesium. Common minerals with these compositions are pyroxene and olivine. Magnesium and iron-rich silicates are heavier and require higher temperatures than quartz and feldspars to melt. So, instead of coming all the way to the surface, they accumulate deeper in the Earth's mantle. While the mantle is richer in magnesium and iron than the crust, most of the iron on Earth is found in the Earth's core. In fact, Earth scientists believe that the core consists primarily of iron and nickel alloys. In a following video, we will discuss in more detail the properties of each layer, but for now, let us summarize what we have learned so far. We have seen that compositionally Earth is divided into 3 layers: the crust, the mantle, and the core. We learned that the most abundant elements on Earth are iron, oxygen, silicon, and magnesium. We have seen that the Earth's crust contains less iron than the planet as a whole, but it is enriched in elements such as aluminium, sodium, potassium, and calcium. Finally, we have learned that the most common minerals in the crust are quartz and feldspars.
Okay, now that you have watched the video, I want you to listen to the conclusion. So the structure of the Earth is divided into layers based on the chemical elements. The crust is composed of silicon and aluminum, which are the most common chemical elements of the outermost layer. The mantle is a layer under the crust down to the core of the Earth. The main components are silicon, magnesium, and iron. The core, the center of the Earth, is made of steel and nickel. Each layer has different characteristics. I want you to answer your book. Go to page 133 on yourself, test yourself 7.1. So check how much you understand this subtopic. Okay? And I'm gonna check your book and place your book on my table. All right? See you again for the next video.